Example 4, and this is all from lesson, I believe is it 12? I should know this. Lesson 13, sketching gradient functions. Okay, so let's have a crack at this one here. Now this is called using the double diff test, and using our knowledge from before, we can have a look at our table and go, okay, double diffs. Well, double diffs is this one here, and you can recognize key features of points. If it's positive and f of x is 0, we can say it's probably going to be a local minimum. If the gradient is 0 and the double diff is also 0, it looks like it's going to be a horizontal point of inflection. So you can use this table to help you with that kind of information. Okay, so here we go. Clearly showing you use of calculus to determine the coordinates of any stationary points. Now, what are they talking about with stationary points? It can either be a min, a max, or an HPI. Now remember, this is saying dy by dx is equal to 0. That's why we're not including VPIs. VPIs have the steepest gradient in a region. So we also meant to state the nature of each. First thing, let's differentiate. dy by dx, 3x squared, take 24x plus 36. Find stationary points, make it equal to 0. Let's be smart about this. Can we make this monic? Yes, we can take out a factor of 3 like that, and then we can cross out that. So now we just need to solve for this here. Can we factorize? Oh, can we go, is it 6 and 2? Take 6, x take 2. Does that look good? Yeah, I think that works. Now what we want to do is we want to solve. So we can say that x is equal to 6 and 2. Okay, now they're saying you're going to find the coordinates, but you also have to determine the nature. Now, that's what they mean by that word nature. Is it min, max, or an HPI? Okay, so our next thing is we know this is a cubic. It's a positive cubic as the coefficient of x cubed is positive. So we know it's going to look like something like this. We can cheat here. We can say this is going to be 2 something, and it looks like that's going to be a max. And this one is going to be 6 something, and it looks like a min. Now, we aren't going to cheat here because we are just going to use our double diff test, and that's not cheating, it's just double checking, okay? So here we go. Let's firstly find the nature of these, and then we'll find the coordinates of those, okay? Now, here we go. Let's switch to a different color. Let's go to blue. We're going to find, firstly, our double diff. So d, now I'm not sure if you remember the notation, but it's quite important. dy squared on dx squared is equal to, we're going to differentiate once more our function here. Okay, I'm going to call that equation 1. We're going to differentiate that once more. So that's our double div. Take 24. So what we've got here, this is our double derivative. Okay, next thing is we're going to do our nature. Okay, nature. Check. So we're going to say, is it a min? It's saying, is it a min, max, or is it an HPI? So we know it's probably not going to be an HPI in this case. Okay, so let's use our nature check. Let's do x is equal to 2 first. So sub it in into a double div. 6, sub 2 in. 12, take 24, negative 12. Okay, let's do our other one over here. X is equal to 6, double div. And you've got 6 lots of 6, take 24, which is 36 minus 24, which is positive 12. So let's think about that. And we can go back to our summary table. We know through our check, it looks like it's lining up with this one here. You've got a gradient of 0, so it's a stationary point, and you've got a positive double diff. We know it's going to be a local min. So therefore we can say this one is a local min, and this one, as it's negative, is going to be a local max. Okay, now this is called finding, using the double diff test to check for the nature of each of these points. Next thing is we're going to find those coordinates. Okay, so let's finish this one off and find the coordinates. Okay, x is equal to 2, x is equal to 6, and we're going to plug this into our original function up here, function y. Okay, so y is equal to 2 cubed, take 12 lots of 2 squared, plus 36 lots of 2, take 15, I get 17, so our coordinate is 2, 17. And over here, y is equal to, and we're putting 6 in instead, take 12 lots of 6 squared plus 36 lots of 6, take 15, all fun, negative 15. So our coordinate is 6, negative 15. So there we go. We've found this, and we can just reinforce the fact that this one here is the max and this one here is the local min. Okay, there we go. I hope this video is useful. In the next video, we'll be doing some more of these types of questions. Thank you.